Okay, mammals, it's time for the first screencast of the year, and this one is going to cover some math skills, particularly on equation manipulating. Depending on what math class you had last year and what one you're in this year, this may be totally review, or it might be mostly review. There could be a few new things in there for some of you guys, but for everybody, it'll be something that you'll get to definitely by the end of your year in whatever your math class you're running with now. But I'm going to cover kind of a short and sweet version of the algebra that we'll be doing in this class. So don't get too overwhelmed that I'm throwing this to you at the very beginning, because it's basically covering kind of the way every equation that you might see in this class is going to look and how to solve for it. So as far as algebra goes for just, my class, not necessarily your math class, this is going to be as bad as it gets. Okay, to kick us off here, hopefully it's something that's old hat, and that's order of operations. And you've probably heard this acronym before in your math class, hopefully. Parentheses, exponent, multiplication, division, addition, and subtraction. And that's the order that you should do your math operations when you're calculating. That's the order that if you type things in, your calculators will do them. So to try and illustrate the point, I've got three equations here with all the values present. And what you should notice is I have the same four values, 8, 3, 2, and 4 in each of the equations, and the same three operations, multiplication, addition, and division. That's present in each one of my little simple examples here, just to drive home the point that we need to do correct order of operations to get the right answer, because all three of these should give us different numerical values. So to start off on this first one, my order of operation is I have a parentheses, and I have to take care of what's inside the parentheses first. So that gives me 5. So now I have 8 times 5 over 4. And that equals 40 over 4, which gets me 10. Okay, this next one, I've lost the parentheses, and I still have the multiplication and division, and I still have the addition. But without the parentheses, I'm going to do my multiplication and division first before I do my addition. So I'm going to do 8 times 3, which is 24, over 4 plus 2. That equals 6 plus 2, and that equals my final answer, which is 8. Okay, and in the last one here, we don't have a parenthesis shown, but we sort of have an implied parenthesis, because all this, the 8 times the 3 plus 2, is all on top of this division line. So it's implying that this step, all of this needs to be done before we do our division. So we'll treat this as if it's a big parenthesis, and inside the parentheses we're going to do our multiplication first. So again, the 24 plus 2 over 4. So that is 26 over 4, which if you typed it into your calculator, you would get 6.5. So that's just a quick review on order of operations. Hopefully this is really old hat. Now let's look at what we're really looking at here, and it's solving for a variable, not necessarily when we have numbers. So you're going to get lots of equations through the course of the year. You might have them written down on a cheat sheet or something, and I'll generally give them to you just in one form. Like this is the equation, force equals pressure times area. It's maybe more of a physics equation, but anyway, I'm using it as an example. And the problem I might give you, I might not be asking you to solve for force. In this case, if you were given a problem, I gave you values for force and area, and I'm looking for you guys to calculate the value for pressure. So we have to do a little bit of algebra to get this equation in the form that we want. So what we have here is we have force equals pressure times area. and I need to isolate the pressure. So I need to move the A, and the operation here is multiplication. So to move the A and cancel it out, I need to do the opposite operation, which is division. And that cancels out my multiplied A. I need to make sure I do it to both sides. So at this point, if I rewrite it, I have the variable that I wanted isolated by itself, and it looks good. Okay, another three-term equation here. We've got the density equation. Perhaps you've seen this before. Density equals mass divided by volume. And in this case, we're pretending that we have a problem where I've given you the density and I've given you the volume, and I'm asking you to solve for the mass. So we're going to do a similar thing that we did to the last problem. I have density equals mass divided by volume. I need to isolate the mass, which means canceling out the volume on this side. And again, the operation is division, so I'm going to do the opposite. So I'm going to multiply both sides by V. V cancels, and if I clean it up, I get that, and the variable that I want is by itself. Alright, same equation, but now we're solving for V. And this is actually probably my number one algebra mistake that I see from my students through the course of the year, and it's solving for a variable in this position when we kind of have a ratio here. So the first thing that I'm going to notice is what I want. It's on the bottom of this division sign, and whenever I have that for the variable that I want, the first thing that I do is I try and make sure that I get it on the top. So I'm going to multiply both sides by V, again to cancel V out, just because that gets V out from underneath the division line. And it's true, I don't have V by itself. I've not done any work to get V by itself, but I've fixed one thing, which is having it on the right side of the division line. So now I'm in this situation. Now I can cancel out this multiply by dividing both sides by D. Slide over here, and I'm going to rewrite that, and that would be my final answer. Now I'm going to quickly show you what the really common mistake that I see is. So I'm going to write this in red because it's definitely not what you want to do. Alright, students recognize that they're looking to get the V by itself, and they need to move the M, so they divide both sides by M, which there's nothing wrong with this at this point. That's legit in algebra. But what they forget is they haven't done anything to change where V is at relative to the division line. So what they actually have here is 1 over V, and they just forget about it. What you would need to do at this point, if you did this, which this is a true mathematical statement, but we don't like to solve for 1 over our answer, is we would need to take the reciprocal of both sides, which is basically flipping both sides, and you see if we flipped both sides, you would get what the correct answer is. So be careful if you go down this route that you don't forget that at this point you actually have 1 over your answer. Okay, now we're going to look at one a little bit trickier, because instead of just one order of operations here, we've got two. We've got m times x plus b. You might recognize this from algebra. This is your form for a straight line, where m is the slope and b is your y-intercept. So we do have to worry about order of operations, which we take care of first, this multiplication or this addition. And if we're dealing with order of operations when we've got numbers and we're calculating, it's PEMDAS. But when we're kind of rearranging things. We're sort of going backwards. So we need to do SADMAP. Subtraction, addition, division, multiplication, exponent, and parentheses. So we're going to take care of everything backwards from the order that we would do if we were calculating this with like numerical values. So when I look at this problem, and I'm wanting to isolate the m, looking to solve for slope, I have to move two variables, the b and the x. The x is multiplied, the b is added, so if I follow my SADMAP, addition comes before multiplication. So I need to subtract b from both sides and cancel that out. Okay, at this point, now I can just do the opposite of the multiplication, which is division. I can divide both sides by x. The x cancels out. And I'm left with this as my correct final answer. Now I'm going to give you one cautionary tale that I see a whole lot. Again, we've sort of got an implied parentheses like what we were looking at on the very first slide here, that it's the y minus b, all of that over x. So it's sort of implied that this has to be done first. I do see a lot of students, and they probably know it in their head, they just don't show what they know. They would do this. This is not the same because of order of operations, and this might also reflect that a student divided by x before subtracting by b, which doesn't follow with SADMAP. So this don't want to do. This is how your answer is, and the parentheses are sort of optional as long as you're kind of clear that both the y and the minus b are over x. Alright, same equation that we just did. We're now going to solve for the b. And this is actually, oh, I don't like that. I want to do it in black, just to be the same. This is actually a one-stepper. If I'm looking to isolate b, I need to move the m and the x. And the m and x are multiplied together, but they are both added to b. Like this quantity, m times x, order of operations, you do that first, get that value, and then add it to b. So what I can do is I can just subtract both of these together as that quantity, all in one step. And I'm done. So that's actually easier, but I do see a lot of kind of silly mistakes. All right, we've got another equation here. It looks rather similar in form to what we just did, but now we have a negative here. And this is an equation that we'll see towards the end of the year. When you see it then, it'll actually be this Greek letter delta G, delta H, and delta S. That delta is just a symbol that means change in. So to make it look clean, we're just going to have G, H, T, and S. And T is temperature, and you're going to be solving for temperature quite a lot when we're using this equation. So this is pretty relevant for later in the year. Okay. Now, one thing that I notice when I'm doing this is I'm looking for T. Right now, it's minus T. And again, like before with solving for volume in the density equation, I didn't want to solve for like 1 over my answer, and I don't want to solve for negative of my answer either. So the first thing that I'm going to do is I'm going to add this whole quantity to both sides. And that, again, it's not getting T by itself per se, but it is getting T positive. So I have delta G, or G for us right now. So in the habit of saying delta G. G plus T times S equals h. And now I can follow my SADMAP, which is I need to take care of the addition before I need to take care of the multiplication. So I'm going to subtract g from both sides. So g cancels out, got t h minus g. And now I can follow my order of operations and divide both sides by s. And again, what I'm looking for is kind of the implied parentheses that the h minus g, this whole quantity, is over top of s. So be definitely using this form later on. Alright, we're going to end up here with two more equations that are trickier than they look. This is the equation. This is actually the law of gravitation worked out by Newton. And this is the force of gravity equals, this is a constant times the mass of one object times the mass of another object divided by r squared. And this r is like the distance between the two objects squared. So you could figure out like the force due to gravity if we took your mass and the mass of the Earth and divided it by the distance between you and the center of the Earth squared. So pretty cool. Explains why if you go up to the top of a mountain, you're getting further from the center of the Earth, so this number gets bigger. You actually weigh less because you're dividing by a larger number. Random trivia there. So we're going to solve this for m1, one of the two masses. Okay. Some students get thrown off because we've got an r squared here. We won't have to worry about taking the square root to get rid of this r squared unless we were actually solving for r. But here we're just solving for m1. So I'm going to take care of that first. I'll multiply both sides by r squared so that my r squared cancels out. Okay. Now we want to get m1 by itself, so we need to move the g and the m2. And since those are both multiplied by m1, we can actually divide by them in the same step. So that's actually not that bad, even though it's a big kind of ugly looking equation with 5 variables. Still only 2 steps to solve for the one that we were looking for. And we would do the same steps whether we were solving for g or m2. We would just divide out by the 2 that we didn't want, leaving the 1 that we did. So if I asked you to solve for g or m2, it would be the same steps. Alright, last equation that we're going to look at here. This is one, students see this and they see the b and they see the parentheses, and I guess they're so used to doing this in math class, the first thing that they want to do is distribute this b out to the c and the d inside the parentheses, and that is actually going to make your life more complicated if you do that, because you're just going to end up undoing that distributing, and it's going to make your equation look messier. So we're solving for b right now. And it's b times this quantity, c minus d. So if I want b by itself, just like I could divide out by the quantity of g and m2 in the previous problem, I can divide out by this whole quantity. And that's it. One step. So I'm showing that to you so that you know to avoid the temptation to distribute this b. Some of the work has already been done for you in simplifying this to get the c minus d as its own quantity. It's already been factored out. So all you have to do is divide. All right. Last thing, same equation, but just to be nasty here, I want to solve for another one of these negative variables, just to make sure that we cover that twice, because I see a lot of mistakes with the negative sign. And again, we're not going to distribute this b. Since I'm looking for something inside the parentheses, I'm going to get rid of that b just by dividing by it, because it's multiplied by this quantity, so if I divide by it, it's gone on that side. And now I can even drop the parentheses because I don't have anything on the outside of them, so there's not really a need to show parentheses c minus d. And like with the g h minus t times s, I'm looking for this negative value, and I don't like that. So the first thing I want to do at this point, even though it's not really getting d by itself exactly, it's getting my answer positive. So I'm going to add d to both sides. Alright, so now I've got my answer d to myself. Hey, notice this isn't that like whole quantity like some of the ones that we've shown. So that's why it's really key to be clear when you're showing this, because mathematically this is communicating a different thing. So be clear with that. That's actually the way it needs to look in this case. And so now I just want d, so I need to subtract a divided by b, and I can do that. That is very ugly. Gotta buy a stylus. I can subtract that fraction from both sides. I don't have to multiply or divide, which is a lot of students think they need to do that because it's dividing. If I want d, this fraction here is added to d, so I can just subtract it. And it's gone. And there's our final answer. All right. Thanks for watching this screencast. I hope it helped you. It should be pretty similar to all the problems that you'll see on your practice set.